Hi guys, and welcome to this video on catalysts. In a previous video we looked at factors that affect the rate of reaction, and we focused on temperature, concentration, pressure and surface area. And in that video we said there's one more thing that we need to look at that affects the rate of reaction, and that's catalysts. Now importantly, catalysts do this: they increase the rate of a reaction but are not used up in a reaction. So normally when you write your equation with reactants on one side and products on the other, a catalyst won't actually be written down in this equation. It's something extra that's useful to speed it up, but it's not actually used up and it's not actually reacting with anything. Essentially what catalysts do is provide a surface for the reaction to happen on, that brings the reactants together and speeds up the reaction. So a lot of catalysts are from the transition metals, which are in this middle block of the periodic table. A lot of these transition metals become good catalysts, so things like iron, manganese, nickel and things make good catalysts. A few reactions that you might have heard of already that involve catalysts are things like cracking from C1, the hydrogenation process, okay, that requires a nickel catalyst, and also if you're looking at C3 later on, the Haber process as well, that uses an iron catalyst. So you might need to think about one or two reactions that you do throughout your course that involve catalysts for your exam. Now what catalysts do is they provide a pathway, an alternative pathway for the reaction to happen. That's how they speed it up. They provide an alternative pathway. And that pathway has a lower activation energy. So we said in a previous video that when the particles collide together that are reacting, for a reaction to happen they need to have a certain activation energy. And what the catalyst does is provide an alternative pathway with a lower activation energy. I'll just add that bit on there, with a lower activation energy. And if you've got a lower activation energy, it means you can put less energy into the reaction for it to happen, which is also going to lower the cost for industry as well. So with catalysts you mean less energy needed for the reaction to happen and a lower cost, okay, which is really good for industry, and that's why they use catalysts, because they can reuse them again and again because they're not used up in the reaction, and they'll allow the reaction to happen faster when perhaps you can't increase the temperature anymore, or you can't increase the pressure anymore because all the equipment becomes too expensive. You can use a catalyst instead. So if I draw this on a little energy diagram to help you, these come up more in C3. So if we put on one side energy of the reaction and just over time, we'll start off with the reactants and we end up with products. So in this case the reactants have more energy than the products, and for the reaction to happen you'll need that activation energy here. For that reaction to happen, the particles need that activation energy. And all the catalyst does then is provide an alternative pathway for the reaction. So rather than the reactants having to follow this pathway with higher activation energy, all a catalyst does is just provide an alternative pathway for the reaction to happen at a lower activation energy. Okay, so if the reactants here turning into products, you want the lower activation energy pathway, and that's what the catalysts provide. So that's our final way then to increase the rate of reaction. So in summary, we've got temperature, concentration, pressure, surface area, and catalyst. Thank you very much for listening. If that was useful to you, please like the video and subscribe.